All right, y'all start looking at the do now, and we will go over it in a few minutes after we give time for everybody to join. Okay, so Daniel's Wi-Fi, Aiden ClassLink. Got it. All right, make sure you're looking at the do now, and we'll go over it in a few minutes. I'll wait another minute or two before we get started. starting to look at the do now for today. So number one says, what happens to the temperatures as we go up through the atmosphere? What do you notice as we're going up? What's going on with the temperatures?
I said it gets cold. I mean, it gets cooler.
They're getting cooler. So you could say that for the troposphere and the mesosphere. But what's happening in the stratosphere and thermosphere?
It's getting warmer.
Yes. So they vary. So troposphere is getting cooler, stratosphere warmer, mesosphere cooler, thermosphere warmer. So for one, you could say troposphere, mesosphere getting cooler, stratosphere, thermosphere hotter. Right, 2 says which layer is the hottest?
Thermosphere.
Thermosphere. All right, 3, which layer is the coolest?
The mesosphere.
Yeah, it's the mesosphere. You could say mesosphere and thermosphere kind of, because they both do have some of the coolest parts. And then the last one, what layer are we in?
The troposphere.
Yes, troposphere. All right, once you've got all of those typed on your do now and you've got that submitted, take out your atmosphere science doodle notes because those will be very helpful for today. Take those out, have those where you can look at them. And then pull up from Canvas this worksheet where it says atmosphere and seasons practice. So when you get it pulled up on Google Docs, make sure you click file and make a copy so you can type on it. I'll give you a second to get that pulled up and have a copy made. And I'm going to go through and talk you through some of them from each section and then let you finish the rest on your own. But there are some that I do want to talk about and kind of explain from each little part. So I'm going to go back to where I can write on this. Does anybody still need another minute? Sounds like we are ready to go. So I'm going to jump around on a few different numbers on ones to talk about, and then after I go through the ones I want to talk about, I'll let you go back and fill in the others. But so we'll start off with number 1. It says which location receives the most solar radiation on this diagram because the sun's rays are the shortest. So looking at our sun's rays, which one has the shortest?
The Tropic of Capricorn.
Yes, this arrow is our shortest one, so it is the Tropic of Capricorn. All right, and then we're going to jump down to number 5. All right, y'all are very off topic in the chat over there, so let's keep up with where we're at. 5 says which tropic receives less than 12 hours of sunlight per day on this earth? So it's asking for the tropic. So Tropic of Cancer is here. Tropic of Capricorn is here. Which one of these would be receiving less than 12 hours of daylight?
Tropic of Cancer.
Yes, it's further away from the sun. Yes. So it's going to be getting less sunlight and less overall time of sunlight. So 5, Tropic of Cancer. And then let me pull up another picture where we can see the rest of the questions here. Dang, I closed off 7 on that one, so I guess let me go back to the first one. Can at least see part of it. So looking at 7, which is primarily responsible for the seasons? So which one of these reasons causes our seasons? Is it the rotation of the earth around the sun? Is it the tilt of the earth on its axis? Is it the spin of the earth each day, or the varying distance of the earth and the sun? Which one would cause our seasons?
The tilt of the Earth on its axis of rotation.
Yes, so the tilt is the cause. If our earth was straight up, that means year round, we're going to constantly receive the same amount of sunlight. So the only differences we would have is day and night. If we were straight on our axis, we would receive the same amount of sunlight year round, no matter what. The only time we would have less sunlight is when we're facing away from the sun and it's nighttime. Yes, I am going to post this on Canvas. Okay, so I'm going to go back to my picture of 8 and 9. This one. I have my little globe here, so let me turn on my video and get my lights to come back on in my room. I don't even know how I can see myself here. Do I have to stop screen sharing for you to see me, or can y'all see me?
We can see you.
Okay, because I can't see myself on here.
You.
Okay. So I've got a globe. Flip the switch. What are you talking about? This assignment is posted on Canvas, the Google Docs. So let me find some tape. All right, can y'all see this? I've got an orange little puff ball near the poles, and then a yellow one. Put it actually at the equator, on the equator. Y'all see that?
Yes, ma'am.
Okay. Check the check real quick. Yes, you click File and make a copy. So when this Earth is spinning, which dot is actually moving the fastest?
The
Yellow one.
The yellow one, because the yellow one has a greater distance it has to go around when the Earth spins, because it's at a wider part of the Earth. This orange one only has a short distance that it has to go to make a full circle versus the yellow one. So the Earth is spinning the fastest at which location? Where's my yellow one?
The equator.
Yes. So the Earth is spinning the fastest at the equator, and then my orange one is up here where? For the slowest.
North Pole, I think.
Yes, the poles. Because it would be the same if I had an orange one down here on the bottom. So spins the fastest at the equator because it has a greater distance it has to go around. And it spins the slowest at the poles because they have less distance to go around. Yes, I got that about Aiden, and I got Daniel with his Wi-Fi, so I know about them. We're good. Thank you. Okay, so did that help you understand a little bit of what I'm meaning there?
Yes, ma'am.
So we are going fastest at the equator and slowest at the poles. Let me clear this out and we'll go to the next section. All right, for number 1, which layer, looking at this graph here, is closest to the sun? See, this says height above Earth's surface. So which one would be closest to the sun?
The exosphere.
Yes, exosphere. Right, and then going down to number 10, I don't have it on this page, but I want you to still be able to see the graph. So which layer has the majority of air molecules?
Is it the troposphere?
Yes, troposphere, that's where we are. We have the most air here. Just think about it, when you go in an airplane or someone goes on a spaceship, they have to pump in air and oxygen because there's not enough in these higher levels for us to breathe. So we definitely have the most air molecules in the troposphere. And then 11, which one is the layer with the lowest atmospheric pressure? Yes, exosphere. Thank you, Kate. So again, as we go up, we start to lose atmospheric pressure. Same thing again with airplanes and spaceships. Those cabins on those planes and the spaceships have to be pressurized because it's not enough atmospheric pressure the higher you go for us to be able to survive. So we have to have pressurized cabins in the planes and on spaceships if we're going high enough. All right, I'll leave the rest for you to do on your own. A lot of those you can find directly on the doodle notes. Let's go to the next section, the part 3. All right, 1 says, what is the source of energy causing these circular patterns? So each of these are either A, B, or C, but what is the source of energy that's causing these patterns to happen? So why is air moving in these circles? What is that source of energy? All right, well, let's back up. What's happening right here? We're going up. What is that arrow representing?
Hot air rising?
Hot air rising. What makes the air hot?
The sun.
Yes. So our source of energy causing these patterns is solar radiation. It's the sun. All right, for 2 and 3, you can do those on your own. Make sure you tell me if they're warm or cool, and if they are more or less dense for each. So those are the 2 points that I want you to tell me for 2 and 3. 4 you can do, it's definitely on your doodle notes too. All right, moving into part 4. Which diagram represents the sun in winter and temperate locations?
B.
Yes. If it's winter and we're in a temperate location, so wintertime, the sun is at a greater angle, further distance. We're not getting as much direct heat and sunlight. Right? What would the sun look like in a temperate location in the summer?
A.
Summertime, temperate location, we're getting more direct sunlight, it's warmer. Which one represents the sun at the equator during most of the year?
A.
A. around the equator, they're pretty much always getting this near direct sunlight. It's hot there year round. And then which one represents the sun at the poles?
B.
B.
B. They're definitely getting a lot less direct sunlight. All right, now going to part 5. This is where we're gonna get a little bit tricky. So somebody have their doodle notes in front of them?
Yes, ma'am.
Yes, ma'am.
So look at your picture on your doodle notes and look at this picture. What can you notice that's different? Anybody notice anything?
The axis is tilted a different way.
Yes. So on your doodle notes, your axis is tilted this way. So if this is opposite, what is that going to tell you about the dates and seasons on your doodle notes compared to here?
That they're going to be the opposite of what our doodle notes say.
Yes, exactly. So one asked us, which letter is going to represent June 21st? So where is June 21st on your doodle notes?
D. No, I mean, D, yeah.
On your doodle notes, it's over here. So where's June 21st going to be on this picture?
B.
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 Exactly. So we'll do a couple of these just to get your brain used to the fact that it's opposite. And I do that on purpose because if this pops up on the AP test, there's no telling which way they're going to have the axis tilted. So I don't want you to get used to just the way we did it on the doodle notes. And then when you see it a different direction, you don't realize that there could be a difference. So which one would be March 21st?
A.
A.
Because on your doodle notes, it's C, so it's opposite here. It's A. And then let's look at, okay. 5. What letter represents the summer solstice in the northern hemisphere?
B.
Yes. And then which one is our vernal equinox?
A.
A.
Yes. And then which letter represents 12 hours of both daylight and dark?
B.
C. C.
Sure. C is correct for one of them. And then what's the other one?
A.
B.
A.
C and A, right?
Yes. Because remember, your summer and your winter solstices, that is when you're having 24 hours a day, 24 hours in certain parts, and 24 hours of night in certain parts. So it's not going to be your summer and winter. Your fall, spring is when you're going to have your equal hours. Okay. Now let's go down to part 6, the last section. Which one is it? All right, which one has normal atmospheric conditions on a smoggy day? So they're meaning, you know, the pollution coming from this little factory. So which one is normal conditions?
A.
A, yes. And then which one is an inversion layer?
B.
B. Because remember, normal conditions are the air is warmer towards the ground and gets cooler as we go up through our troposphere. When it's inverted, we have this pocket of warm air trapping cool air down towards the ground. And then you can describe the two ways inversion layers form from the doodle notes. So that is all I'm going to go over on that. So now you can go finish this on your own. Make sure you have made your copy of it and don't forget to submit it when you're done. So y'all are good to log off, work on that. Don't forget to submit. Y'all have a good day.
Bye.
Bye.